Here's another segment for story problems. Now these are going to be the most difficult addition and subtraction word problems, including multi-step operations. Let's just see if you can do it. If you wanted to pause it, feel free to see if you can solve these problems prior to me going ahead and doing it. I'm going to go through pretty quickly here, so use that space bar if you need it. All right, let's look. In the year 2022, the Dodger Stadium sold 17,960 tickets to their games. In the year 2023, the stadium sold 1,872 more tickets than the year 2022. How many tickets did the Dodgers sell in 2022 and 2023? Pause it if you need to solve it on your own. If not, I'm going to go ahead and solve it. I know there's a lot of numbers here. However, that doesn't mean that we just throw numbers together and start working on them. Remember, these are stories. They are not just word problems to see if you know what to do. Understand the story first. In the year 2022, meaning whether it's a couple years ago or it's just a specific date, it doesn't matter. It's a time that's talking about what happened in that stadium. Now, it's very plain simple. The Dodgers Stadium, they ended up selling 17,960 tickets. Now that is already there. That is how much they sold. There's nothing else to do with that. So in year one, we'll say it's 17,960 tickets. Now in year two, we need to read very carefully. 2023, the stadium sold 1,872 tickets. But do not stop there. Look what it says right after it. The stadium sold 1,872 more tickets. That means that there's something going on. They didn't sell 1,872 tickets. They sold 1,872 tickets more than the year before, which means it's a math problem. So, I'll say it again. In 2023, they did not sell that number. They sold that many more tickets than the previous one, which means this year they are selling in 2023 1,872 tickets plus the 17,960 tickets that were in the 2022 year. So now I got year one and I have year two. Now look at the question. How many tickets did they sell in both of those years? So again, you are not just adding these two numbers that you see right there. You're actually adding all three numbers up. Year one is 17,960. Year two, you're going to add part of the problem here. And 17,960 again. But let's take it into parts first. 2 and 0 is 2. 6 and 7 is 13. 1 and 9 is 10 plus 8 is 18. 7 and 1 is 8 plus 1 is 9. 19,000. And now I'm going to finish the problem because all I've done is just this. You cannot leave out that other part. So I'm going to add that again. 17,960. I'm going to add them up. 2 and 0 is 2. 3 and 6 is 9. 9 and 8 is 17. Plus 1 and 9 is 10. 7 is 17. 1, 1, 1 is 3. The total for those 2 years is 37,792 tickets. Another difficult one. Mary sold 2,455 paintings during an art show, and her friend Joseph sold 1,488 more paintings than Mary did at that same art show. So how many tickets did both Mary and Joseph sell at the art show? Now, I can do this. Mary is pretty simple. It already tells you what she sold. Her friend, however, Joseph, he sold, as we can see, 1,488 more paintings, which means it's 1,000 more paintings than Mary did, which means we're taking Mary and we are adding up what she had and the amount that Joseph had more of. Now look at the question. How many paintings did both Mary and Joseph sell? So now we're going to add Mary and Joseph. Now let's just find Joseph for a second. Joseph alone is 1,488 plus Mary's. Let's find out how many tickets he actually sold. Or, sorry, paintings. We have 8 and 5, which is 13. 8 and 5 is 13 plus 1 is 14. We have 1 and 4 is 5, plus 4 is 5. There we go. We have 9. Oops, sorry. I spoke too quickly. 9. And then we have 1 and 2 is 3. So Joseph alone sold 3,943. But now we need Mary's, because this is only Joseph, and they wanted Mary and Joseph. So now we're going to add both of them up. So we have 2,455 for Mary, and the Joseph's 3,943. Add them up. 5 and 3 is 8. 5 and 4 is 9. 4 and 9 is 13. 5 and 1 is 6. So the total that they both had is 6,398 paintings at that art show. Scientists were recording the widths of various redwood trees in a park. They noticed that one group of trees was 948 centimeters while another group was 28 centimeters smaller. What is the difference of the widths of these two groups? So here's what we notice. We have something already given to us. One group and another group. So group 1 is 948. So the average centimeters that those groups had was 948 centimeters. Now let's look at group 2. That other group was 28 smaller. And typically in math, when you're trying to figure out how small something is compared to something else, that means that you are subtracting. So that means I have to take 948 and take away the 28 centimeters that are smaller than that group. Now look what it's asking you to do. What's the difference of these widths? So we're not adding them like the last two problems. We are finding the difference between them. Here's what this means. I am going to take the difference of group 2, and then I'm going to find the difference of group 1 and 2. So one step at a time, I'm doing group 2 first, because that's two different operations, so I'm taking one operation at a time. 948 minus 28. 8 and 8 is 0, 4 and 2 is 2, 9 and nothing is 920. So for group 2, it's 920 now. I have that total. Now I want to find the difference between group 1 and group 2. So I have 948, and I'm finding the difference of group 2, which is 920, as we just found out. Difference means subtract. So 8 minus 0 is 8. 4 minus 2 is 2. And 9 minus 9 is nothing. So the difference between those two groups is 28 centimeters. Now the hardest problem. A company was tracking the first quarter sales of different employees at a local paper company. Dwight sold 10,892 reams of paper. And Jim sold 81 more reams of paper than Dwight did. If Stanley sold 892 reams of paper less than Jim, so how many reams of paper did all three employees sell? So we know now that there's a lot of operations going on in here. Let's take it one step at a time. We that Dwight sold 10,892 reams. So that's a definite total for him. So we're going to write down 10,892 for Dwight. So that number's set. There's nothing else to do in that number. Now let's look at what Jim has. Now Jim says he sold 2,881 more reams than Dwight, which means I need to take that and add Dwight's total to that, as he sold more. So now I got Stanley. I have another employee. He sold 892 reams of paper less than Jim did. As you may know, less means subtract. So that means I need to find out what Jim did so I can have the total for Stanley. So Jim, as we recall, was 10,892 and 2,881 more. Line up your place values. 2 and 1 is 2. 3. 9 and 8 is 17. 1 and 8 is 9 and 8. That is 17. So carry the 1. 1, 0 is 1 plus 2 is 3. And 10,000 plus nothing is just 10,000. So we have 13,773 just for Jim. Stanley has 892 less than that 13,773. So, how many reams did all three sell? So now that I found that out, I can take Dwight's, and I can take Jim's, and I can take Stanley's. But I haven't found Stanley's yet. So, let's go ahead and do that. I have 13,773 minus the 892 less that he sold. So, 3 minus 2 is 1. I cannot do 7 minus 9, so I have to borrow, and that becomes a 6. I have to borrow then from this one as well later on. 17 minus 9 is going to be 8. 6 minus 8, as I saw, can't do it, so that's going to become a 2, as that becomes a 16. Minus 8 is 8. 2 minus nothing, there we go, 1, finally. So there's Stanley's. So I have all three employees now. And it says, how many reams did all three sell? Which now means I'm going to have to add all three of those numbers up. So what I need to do is, of course, have more room, because I'm going to need to write some larger numbers out here. So the first one, Dwight, 10,892. Then for Jim, 13,773. Let's go ahead and add those two up first to get the total for just them two. Then I'll add Stanley's. 2 and 3 is 5. 9 and 7 is 16. 15 plus 1 is 16. Carry the 1. That's 4 and 2. 24,665. Now I can go ahead and add Stanley's. 12,881. 5 and 1 is 6. 6 and 8 is 14. 6 and 8 is 14 plus 1 is 15. 1 and 4 is 5 plus 2 is 7. 2 and 1 is 3. The total amount of reams of paper that all three employees sold is 37,546. That was a lot of work for that problem, and that is why it is a level 3, very spicy problem. Thanks for joining me. If you would like to try these problems over again, go on ahead. If not, keep on practicing.